Hello, welcome to PowerLearn Science and Maths TV. In this lesson, we are looking at nature of matter and its classification. In the previous lesson, we learned about matter, where we saw that matter is anything which has mass and occupies space, or matter is anything which has mass or weight and has volume. Then we learned that we are generally surrounded by matter. We are surrounded by matter, where we saw that in our various homes, the items we use are full of matter. In fact, they are matter. So your textbook, your calculator, the cups, the pen, the cooking utensils, our shirts, water, steel, all these are examples of matter that we are surrounded by. But today, this lesson focuses on the nature and classification of matter. Now, when we talk of the nature of matter, we are simply talking about the form in which matter appears. Right? The form in which matter appears. That is the nature of matter. Now, you agree with me that in our environment, taking a look at the things that surround us, you realize that they come in different forms. All right? But we can group all these forms, or we can group all the matter that we are surrounded with into three different forms. Now, before I move on, let me be quick to add that the different forms in which matter appears or matter occurs is what we call the state of matter. It's simply the different forms in which matter appears. That is what we call the state of matter. You agree with me that all the items we are surrounded with, all right, comes in primarily three different forms. If the item is not in the solid state, it is also in the liquid state or the gaseous state. All right, so these are the different forms in which matter appears or occurs. It is either it is solid, liquid, or a gas. Now, an example of a matter which comes in a solid state, we can talk of our calculator, which is solid. We can talk of textbook. We can talk of our cooking utensils, all right? We can talk of cups, knife, and so on. Examples of matter which comes in liquid state, you can talk of water. You can also talk of the drinks we buy, liquid state. Anything that is liquid is matter in the liquid state. Now let's look at matter in the gaseous state. We can talk of the gas for cooking, the gas in a cylinder is matter in the gaseous state. We can also talk of the air we breathe in. It's also matter in the gaseous state. So primarily, these are the three forms or the three states of matter. So generally, we have three states of matter, which are the solid states, liquid states, and the gaseous state. Now, there will be a lesson where we'll talk about the various states of matter. We'll take a look at them into details. But for now, what I want you to know is that we have three states of matter. Now, let's look at classification of matter. Classification of matter. Now, for classification of matter, we are simply looking at another aspect in which matter comes in. All right? Even though we know the forms of matter, but in details, we can classify the forms of matter. All right? And that classification is what we are looking at. So, generally, if you take a look at matter, aside the state of matter, we can classify matter into pure substances and mixtures. So, matter can come in as either pure substance or a mixture. All right. Now, pure substance can further be broken down into elements and then compounds. And mixtures can be broken down into homogeneous mixture and then heterogeneous mixture. So now we are going to take a look at what a pure substance is, what a mixture is, then we'll take a look at the subdivisions. So, what is a pure substance? What is a pure substance? Now, a pure substance is simply a substance or matter with a fixed chemical composition and characteristic properties. That is what a pure substance is. Now, for pure substance, what we are trying to say is that we are talking about any substance which is pure chemically, not physically. A substance which is pure chemically. And a pure substance also has what you call fixed chemical composition. All right? And then it has fixed characteristic properties. So that is what a pure substance is. Now, pure substances can be classified or grouped into elements and compounds. All right? Elements and compounds. Therefore, examples of pure substances are all elements and all compounds. What it means is that examples of pure substances are the same as examples of elements and compound. So if a substance is a compound or an element, it is a pure substance. It is a pure substance. So let's look at what an element is. Let's look at what an element is. An element is simply a chemical substance made up of only one kind of atom. What it means is that if I'm talking about, let's just say I'm talking about a substance like sodium, right, which is an element. You realize that in sodium, there is no other substance apart from this sodium. All right. And so because of that, we say that this is an element because it is only made up of sodium atom. All right. It doesn't contain any other atom. It is made up of only sodium atom or only one kind of atom. All right. So that is what you call an element. So an element is defined as any chemical substance made up of only one kind of atom. Another way by which we can define an element is a chemical substance which cannot be broken down into any other substance through any chemical means. What it means is that this is made up of only one kind of atom. All right. And that kind of atom here is what we call the sodium atom. Now, for this to become an element, what it means is that it cannot be broken down to get any other substance. So what it means is that we cannot break this one down to go and get, let's say, sulfur. All right. To go and get sulfur. So an element is simply any substance which cannot be broken down into any other substances through any chemical means. So you can't use any chemical reaction to transform sodium to sulfur. It is not possible. So any element which cannot be broken down into any other substance chemically is what you call an element. So one distinct feature of an element is that it is made up of only one kind of atom. You won't find any atom apart from it. Now, the next division of pure substance is what we call compound. Now, when you put two or more different elements together, we form what we call a compound. But before that, let's look at some examples of elements. Some examples of elements include sodium, which has a symbol Na, chlorine, sulfur, etc. In fact, we have more than 109 elements according to the periodic table. So all the elements you see on the periodic table are examples of elements. You can write them as examples of elements. Yeah. So we have over 109 elements according to the periodic table. So these are examples of elements. Now you can also write these examples as examples of atoms. All right, because element is made up of only one kind of atom. So it means that in sodium element we have just sodium atom. In chlorine we have just chlorine atom. And so all these examples can also be written as examples of atoms. Now let's look at compound. What is a compound? Now, I said that when you put two or more different elements together chemically, we form what you call a compound. All right, so a compound is a chemical substance or simply a substance formed by the chemical combination of two or more different elements or atoms in a fixed ratio. So in compound, the chemical combination doesn't just happen anyhow. It happens in a fixed ratio. An example of compound is water. All right? And this is a chemical formula for water. Now, what we are saying is that a compound is formed by a chemical combination of two or more different elements. So we have two different elements which are hydrogen and oxygen. Then it says that in a fixed ratio. Now, water is a combination of hydrogen and oxygen in a ratio of 2:1, meaning that there are two hydrogen atoms and one oxygen atom. Another example of a compound is table salt, which has a formula. This is called sodium chloride. In sodium chloride, it is made up of two different atoms. We have sodium, we have chlorine, and the ratio is what? 1:1. Another example is glucose, C6H12O6. In this case, you can see 3 different atoms combined together, and they are in a ratio of 6:12:6, which is 1:2:1. All right. So one thing about compound is that they are formed by chemical combination of 2 or more different elements or atoms in a fixed ratio. So that is what a compound is. Now, having done with what pure substances are, let's look at mixtures. Now, what is a mixture? Now, if you put 2 or more, we've learned about compounds. Now, if I put together 2 or more compounds physically, not chemically, I'll end up getting what we call mixture. All right. So let's say I have sodium chloride, which is a compound. I'm adding it to water, which is also another compound. I'll get a mixture. All right. I'll get a mixture. So it's just like dissolving, let's say, salt in water, or just simply putting salt in your soup. That is a mixture. All right. So for a mixture, we are just looking at the physical combination. We combine the component of mixture physically. So it is the physical combination of 2 or more pure substances. We've learned that pure substances are elements and compounds. All right. So if I'm putting compounds together, I'm getting a mixture. All right, a mixture. So that is what, in any ratio, we must not forget this. In any ratio. So one thing about mixture is that there is no fixed ratio. All right, there is no fixed ratio. It comes in any ratio. An example is if you are forming a mixture between sand and water, there is no fixed ratio. All right. You can't write the chemical formula for addition of sand and water. As a matter of fact, when you are even fetching the sand, you don't know the quantity of the sand particles you are adding to the water. You don't know. All right. You don't know the ratio of the components you are adding. So a mixture occurs in any ratio. All right. It can be 2:1. It can be 3:1. You don't know. All right. So that is what a mixture is. Let's take note of physical combination and then 2 or more pure substances. All right. And mostly compounds. Now, mixtures have the following properties. The first one is that the components of mixture keep their physical property. For example, if I'm adding sand to water, all right? Now, the fact that I'm adding sand to water doesn't mean that the property of sand will change. No, the sand will not change. As a matter of fact, after pouring the water away, the sand will continue to be sand. All right? If you are adding, let's say, gravels to water, it doesn't change the property of the gravels. No. If you pour the water away, the gravel will still maintain its physical property, will still be gravel. So they keep their physical properties. Then the second property of mixture is that the components of the mixture are not in a fixed ratio. They are not in a fixed ratio. All right, and I've explained that already. Then the last thing is that the component of the mixture can be separated by mechanical or physical means. Let me use this same example of sand and water. So I have sand and water. I want to separate the sand from water. What do? You can't use chemical method to separate the two. You can use physical method. And what is this physical method? You just pour the water away, and at the end, you get your sand, and then you get your water. You have gravels and water. You want to separate the gravels from the water. You just pour the water away, and you are left with your gravels. Now, there are two types or groups of mixtures. We have what we call homogeneous mixture, heterogeneous mixture. Now, what is homogeneous mixture? Now, from the prefix homo simply means same or uniform. All right? So this is the same as uniform mixture. Homogeneous mixture is the same as uniform mixture. Now, there are so many mixtures we see around, and in our daily activities, we form mixtures, adding garri to sugar, adding salt to soup, even preparing stew. All right, it's a mixture. All right, so we form mixture all over. Adding oil to water, it's a mixture. All right, so these mixtures that we see, or these mixtures that we form in our daily activities, some of them, they are uniform, and so it becomes what you call homogeneous mixture. And some of them, after mixing, they are not uniform, so they become heterogeneous mixture. So homogeneous mixture is a mixture where the components mix completely or uniformly. All right. So for homogeneous mixture, after adding the components together, what it means is that they mix completely. And by mixing completely, I mean that at the end of the mixture, you can't identify the individual component of the mixture. All right. An example is salt solution. It's homogeneous mixture. Why is it homogeneous mixture? It is because there is uniform mixture. Now, if you add salt to water, it gets to a point where you can't identify the salt. You would think that it is just water. All right. So one thing about homogeneous mixture is that after the mixture, the different component of the mixture cannot be seen. It is seen as just one component. Another example of homogeneous mixture is the sea. All right. The sea is just like salt solution. It is made up of salt, water, and other substance, but we don't see the other substance. Another example of homogeneous mixture is alloys. All right. Now, in our various homes, most of the utensils we use, right? For example, the spoon. All right, they are made from what you call, they are stainless steel, and stainless steel is an alloy. All right. So, if you take the stainless steel for example, is made up of iron, made up of carbon and other elements. All right. But you can't see the iron and then the carbon. All right. They have mixed uniformly. So that becomes homogeneous mixture. Another example of homogeneous mixture is the air we breathe in. Air is a mixture of gases such as oxygen, nitrogen, carbon dioxide, and other gases. But we can't see the different component of the air. And so it makes it homogeneous mixture. All right, it makes it homogeneous mixture. Now, I want you can pause the video and then brainstorm other examples of homogeneous mixture. So, one thing you have to know about homogeneous mixture is that I want you to take notice of these properties. Homogeneous mixture has definite composition. specific properties, and the different components cannot be seen. Now, definite composition simply means that, for example, let's take salt solution. Now, if you fetch any aspect or any part of the salt solution, you realize that it contains salt. All right. So if, let's say, the salt is too much in the water, any part of the solution that you fetch will be salty. And so it means that the composition is fixed. All right. The composition is fixed. So any part of the solution has the same composition. All right. Then specific properties. All right. So if you fetch any part of, let's say, the mixture, where example, salt solution, any part, it is still salt and water. All right. It is still salt and water. So they will have the same property. Then a different component cannot be seen. I've explained that already. Now, I want you to take notice of this, that all homogeneous mixtures are called solution. All homogeneous mixtures are called solution. So we define solution as the homogeneous mixture of a solute and a solvent. All right. Now let's look at heterogeneous mixture. Now from the prefix hetero, hetero simply means different. All right. Not uniform. So whilst this is uniform mixture, this is non-uniform mixture. So for heterogeneous mixture, it is a mixture where the components do not mix completely or uniformly. All right. There is no uniform mixture between the components of the mixture. All right. An example is if you add oil to water, you realize that the two components of the mixture become separated. So we can know that this is oil and this is water. The fact that we can be able to identify the different components makes it heterogeneous mixture. All right, makes it heterogeneous mixture. If you add, let's say, milk powder, all right, milk powder to water, all right, you get to realize that at a point, some of the milk powder, example is some of the milk powders, if you add it to water, you realize that at a point, you can be able to identify the milk powder from water. So that also makes it heterogeneous mixture. That makes it heterogeneous mixture. All right. Then one thing we must also know is that heterogeneous mixtures do not have constant or definite composition, and the different components of the mixture can be seen. Now, what does it mean to say that they do not have constant or definite composition? Now, because they do not mix uniformly, what it means is that any portion or any part of the solution that you fetch, at some point, if for example, we are taking a look at oil and water, at some point, you have little oil and more water. At some point, you may have more oil and little water. Is that okay? So the composition of the solution that you fetch from the different parts of the solution will not have the same composition. So examples of heterogeneous mixture: a solution of oil and water. Talk of sand and water. We can also talk of gravels and water. You see, all these are examples of heterogeneous mixture. All right. Now, I want us to take a look at some differences between homogeneous mixture and heterogeneous mixture. Now, you can see from here that for homogeneous mixture, the component mix what uniformly, whilst for heterogeneous mixture, the components do not mix uniformly. You can also see from here that for homogeneous mixture, they have definite composition, whilst for heterogeneous mixture, they have no definite composition. Then for homogeneous mixture, the different components of the mixture cannot be seen, whilst for heterogeneous mixture, the different components can be seen. So these are three differences between homogeneous mixture and then heterogeneous mixture. Now, let's also look at the differences between compounds and mixtures. All right. Now, for compound, we learned that it's a chemical combination of two or more different elements or atoms. And this is a physical combination of two or more pure substances. Then another difference is that for compound, it can be separated by chemical means only, whilst for mixtures, the component can be separated by physical means. Then for compound, we've also learned that the components are in a fixed ratio, but for mixtures, the components are not in a fixed ratio. So that is it for this lesson. Thank you for watching and see you in the next lesson.